What's up everyone, welcome back. In this tutorial we're building a fully modular health system in Unreal Engine 5 using blueprints, with damage, healing, death events, and a polished HUD setup. If you want the full project files and future systems, check out my Patreon below. Let's get started. Right-click in the content browser, and create a new folder named Health. Inside the folder, create a new widget blueprint. Rename it to WBP_health, and then open it. In the Designer tab, add a canvas panel, then search for and add a progress bar. Rename the progress bar to PB_health. Set the anchor of PB_health to the bottom left corner. Change the position X and Y values to 104 and -116. Then set the size X and Y values to 197 and 9. In the style settings, change the background tint to black. Set the draw as option to rounded box, then set the corner radius to 3 and change the rounding type to fixed radius. Under the Fill Image settings, set the Draw as option to rounded box, change the corner radius to 3, and set the rounding type to fixed radius. Set the percent value to 1.0, then change the fill color and opacity to white with an alpha value of 0.8. Go to the Palette panel and add a text widget to the Canvas panel. Rename the text to txt_health. Then enable the isVariable checkbox. Set the anchor to the bottom left corner, then change the position X and Y values to 102 and -140. Set the size X and Y values to 85 and 22. Change the default text to 100/100. Then set the font typeface to light, and change the font size to 15. Next, open the event graph. Create a new function called Update Health to handle updating the health bar and text dynamically. Create 3 new inputs for the function. Name the first input health % and set its type to float. Create a second input named current health and set it to float. Then create a third input called max health and also set its type to float. Use PB_health with a set % node to update the progress bar based on the current health percentage. Use txt_health with a set text node to display the player's current and maximum health values. Add a format text node and set the format to current and max inside curly brackets, separated by a /. Then round both the current health and max health float values before connecting them. This keeps the health display clean and easy to read. Compile and close the widget. Next, create a new actor component blueprint named BPC_health and open it. Create a variable named maxHealth. Set its type to float. Enable instance editable, and set the default value to 100. This variable stores the player's maximum health. Create another variable named current health. Set its type to float, and set the default value to 100. This variable tracks the player's current health. Create another variable named isDead and set its type to Boolean. This variable is used to check if the player is dead. Create another variable named canTakeDamage, set its type to Boolean. Enable instance editable, and set the default value to true. This variable controls whether the player can take damage. Create another variable named createHealthWidget, set its type to Boolean. Enable instance editable, and set the default value to true. This variable determines if the health widget should be created. Create another widget named HealthBar class. Set its type to WBP_health class reference. Enable instance editable, and set the default value to the WBP_health widget. This variable stores the health widget class. Finally, create another variable named HealthBarRef and set its type to WBP_health object reference. This variable stores a reference to the created health widget. Next, create a new event dispatcher named onHealthChanged. Add an input called currentHealth and set its type to float. Create another input named maxHealth and set its type to float. Then add a final input named health% and also set its type to float. This dispatcher is used to update UI and other systems whenever the player's health changes. Create another event dispatcher named onDamaged. Add an input called damageAmount and set its type to float. This is useful for triggering hit effects, sounds, or damage reactions. Create another event dispatcher named onHealed. Add an input called healAmount and set its type to float. This can be used for healing effects or UI feedback. Finally, create another event dispatcher named onDeath. This dispatcher is useful for handling death-related logic such as ragdolls, respawning, or game over events. Create a new function called setHealth. Add a new input named newHealth and set its type to float. Inside the function, create a setCurrentHealth node. From the newHealth input, drag out and add a clamped float node, then connect it to the current health value pin. Drag and get maxHealth. Then from it create a maxFloat node. Set the second value to 1, then connect the result into the max pin on the clamped float node. This ensures the health value is always kept within a valid range, preventing it from going below 0 or above the maximum allowed health. Next, call onHealthChanged and connect both currentHealth and maxHealth into their matching inputs. Drag and get currentHealth, then divide it by maxHealth. To do this safely, drag and get maxHealth and connect it into a maxFloat node with the second value set to 1. Connect the result into the division node, then connect the final output into the health% input on onHealthChanged. This calculates the player's health percentage while also preventing divide by 0 errors, ensuring the health bar always updates correctly and safely. Drag in HealthBarRef, then create an isValid node. From HealthBarRef again, call the updateHealth function. Connect currentHealth and maxHealth into their matching inputs. Then connect the result from the previous divide node into the health% input. This checks that the health widget exists before trying to update it, helping prevent errors while keeping the UI synced with the player's health values in real time. Our setHealth function is now complete. Create a new function called damage. Add an input named damageAmount and make sure its type is set to float. Inside the function, start by adding a branch node. Drag and get can take damage. Then drag and get is dead and connect it to a not Boolean node. Connect both of these into an and Boolean node. From the damageAmount input, drag out and create a greater node with the value set to 0, then connect this into the and Boolean node as well. This setup validates the damage before applying it, ensuring the actor can take damage, is not already dead, and that the damage amount is greater than 0. From the true pin on the branch, call the setHealth function. Drag and get current health. Subtract the damage amount from it. Then connect the result into the new health input on setHealth. After that, call the onDamaged event dispatcher and connect the damage amount input into it. This subtracts the damage from the player's current health while also triggering an event dispatcher that other systems can react to. Next, add another branch node. Drag and get current health. Then create a less or equal node and connect it to the branch condition. This checks if the player's health has reached 0 or below, allowing us to detect when the player has died. We will create another function called kill, then go back to the damage function and connect it to the true pin, because the player's health has reached 0 or below. Next, we will set up the kill function. Drag and get is dead. Connect it to a not Boolean node, then connect it into a branch. This checks if the player is already dead, preventing the death logic from running multiple times. From the true pin, set is dead and enable the checkbox. After that, call setHealth and keep the new health value at 0. Then call the onDeath event dispatcher. This marks the actor as dead, sets the health to 0, and broadcasts a death event for other systems to react to. Add a new function called heal. Create an input named healAmount and set its type to float. Add a branch node. Drag and get is dead, then connect it to a not Boolean node. From the healAmount input, create a greater node and set the value to 0. Connect both checks into an and Boolean, then connect the result to the branch condition. This checks that the player is alive and that the healAmount is valid before applying any healing. From the true pin on the branch, call the setHealth function. Drag and get current health. Then add the healAmount input to it, and connect the result into new health. After that, call the onHealed event dispatcher and connect the healAmount input into it. This increases the player's current health, and then broadcasts a heal event so other systems can react to. Create a new function called revive. Inside the function, set is dead to false. Then call the setHealth function and connect max health into the new health input. This revives the player by resetting the dead state and restoring their health back to the maximum value. Add a new function called Initialize Health. Call the setHealth function and connect max health into new health. This makes sure the component starts with full health. Next, drag and get Create Health widget and connect it to a branch. This checks whether the health UI should be created or skipped. Drag and get Health Bar class, then create the widget from it. Connect this to the true pin. Set the owning player to player controller. Then set health bar ref and add it to the viewport. This creates the health widget, stores a reference to it, and displays it on screen. From the widget reference, call update health. Connect current health and max health into it. Then divide current health by max health. Use a max float with the value set to 1 before connecting it into the divide. Then connect the result into health percent. This updates the widget immediately with the correct starting health values. Finally, go to the event graph and call Initialize Health from Event Begin Play. Go to your character blueprint, then simply drag and drop the BPC_health component onto the character. Once added, the health system and widget will work automatically. To test the system, add a keyboard event 1. From the BPC_health component, call the damage function and set a damage amount value. Duplicate the input event and change the key to 2. From the BPC_health component, call the heal function and set the heal amount value. Duplicate the setup again and change the key to 3. From the BPC_health component, call the kill function. Finally, duplicate it one more time and change the key to 4. From the BPC_health component, call the revive function to restore the player. That's going to be it for this tutorial. We now have a fully modular health system in Unreal Engine 5 with damage, healing, death events, and a scalable HUD setup. If you enjoyed the video, make sure to like, subscribe, and check out the Patreon below for the full project files and future systems. Thanks for watching, and I'll see you in the next one.